logic operations. So if any of that seems unfamiliar to you, then that just means you need to go back through the material and brush up on it. Okay. Oh, sometimes the feedback I get, not only in this class, but also like in circuits lab, people say, sometimes I feel like I just got thrown into the deep end on this stuff. But that's true. That often happens. And what we assume is that you'll go back and figure out what parts of it that you don't understand, and that you'll review it yourself. So sometimes I point you to the resources that you'll need to figure it out, but I think, well, not everybody needs to see this. They might have gotten it the first time, and so I don't stop again on it. So if you have to do kind of some looking back on your own, that's okay. That's part of the process. That's just how engineering education works. All right, let's see what kind of terrible things they have for us here. Okay, generate the repeated pattern 99, 187, and 39 on Z. Okay, just from the description, here's what I know. Is that Z, first of all, is not a single bit. It's capitalized is one way I know that. Second, you can't do the numbers 99, 187, and 39 in one bit. I'm going to need multiple bits to do this. Now, if I were the designer of this just from scratch, I would say, well, how big of registers do I need? I need something that's going to hold 187. And so if I figure out how many bits that is, that would be 8 bits. Because 8 bits gives you 2 to the 8 minus 1, which is 255. If I tried to do this with 7 bits, the highest number I could make is 2 to the 7th minus 1, 127. I wouldn't hold it. So I need an 8-bit number. Now, fortunately for me, they tell me that right over here. So good news. Second thing I know is I'm going to have to do 3 different things. So I'm going to have to be putting out 99, I'm going to have to be putting out 187, and I'm going to have to be putting out 39. So I'm going to need at least 3 states to do that. One in which I set Z to 99, one in which I set Z to 187. Okay. So I'm going to add 3 states. Now this is the initial state. All right, and then I'm going to add a second state. And then I'm going to add a third state. Okay, here we go. A nice, pleasing triangle. And what do I want the output to be whenever I'm in the initial state? Well, I want it to be 99. So I write over here, Z equals 99. I think I need a semicolon. Do I need a semicolon? Yeah? Okay.
Is that capitalizing?
I did capitalize it, yeah. I don't know if that's necessary or not, but I did.
It is.
It is necessary? It'll freak out if you don't? Okay. Thank you for working the problems ahead of time. So you can help me work them in class. It's good to have competent friends.
Make a initial state, like a transition there.
Yeah. Oh, I need a transition, right?
Yeah. How do I make an arrow there on the top?
Oh, how do you make this one?
Yeah.
By clicking this box that says initial state. Well, there we go. See, when I click initial state, it pops that arrow up for me. Okay, let's put a transition in here. Uh-oh, I didn't do it right. Insert transition, 1, 2, oh, there we go. I'd like to get it out of the way, but I don't think I don't think it's going to be possible. I can't move that. Okay, there we go, it's the best it is. Now, when do I want it to go? After it does 99, I have to think, well, what kind of decision do I need to make to decide whether I ought to move to the next state and put out 187? Well, for this problem, there's no decision to be made. If I'm putting out 99 now, the next number, no matter what, is 187. So I'm going to move on this transition path no matter what. And when I get to the second state, I'm going to be putting out Z equals 187. Okay. Good. And then after I do that, I'm going to go to the state. Okay. It's a little clunky with the arrows, to be honest.
These are 2 states, or 2 transitions.
What's that?
The arrow that you don't like, there's the 2 states, or 2 transitions. So it's going to be a problem. Like, we should do that again. It should be only 1 circle. But we usually have 2 circles, like, for the transition arrows.
So you mean sometimes we have more than 1 arrow coming out?
No, can you click on that transition arrow, like in
This
here?
one?
Yeah, we have 2 circles on it. That means
Oh, that's just so you can move the arrow around. Yeah, that's just so you can straighten the arrow out if you want to. Then it doesn't do the function of the arrow. And if you get, you know, if you're a little bit picky, then like me, then you got to make sure they're kind of more straight. That's pretty good. Okay. So this third state, we're going to do z equals 39. Okay. Now, if the problem said what we do is put out this sequence one time, then what we would do is we would go 1, 2, 3, and then we would just loop here forever. But that's not what it asks us to do. It's a repeated pattern, so it wants us to do this over and over and over. So we just go back to our original state, and then we'll see if everything works out okay. Okay, so it's moving correctly. Yeah, the box isn't big enough to show the whole thing, I think. So, whoa, this is not right. 39, 99. Oh yeah, it's okay. It's just the box isn't white enough. Maybe because of the resolution of my screen, I don't know.
When I try to simulate it, I get z is not defined.
Really?
Yeah.
Did you make it uppercase?
Oh, capitalized. Yes.
Just talked about that, right? Okay. So, there we go. I think we did it together. Now let's see what the next one is. Oh, wait, it worked. Okay, good. All right. Generate the pattern starting at 17 and incrementing by 3 each cycle. Okay. So, what we want to do here, so it's going to start at 17. Let me get rid of some of this. We'll keep this initial state.
You click on it first, then delete.
You gotta click on it first? It's not letting me click on it. What have I done? Oh no. Broken it.
No, hit resume.
You click on the state and then delete the state. Resume?
You're paused, you gotta hit resume.
Oh, resume, because I had it paused. Oh, I got you.
No,
Okay.
That's the simulation.
That's the first one, right? Okay.
reset.
No, reset will reset the whole problem.
Oh, no, I can't bear to do the first one again.
Yeah, you can, you can jump. I just literally just deleted it.
I can go to the second one.
Yeah.
It's not
Then you
like-
have to click on it from the top right.
Like here?
Yeah.
Click
Start.
start. Click start.
Okay. You've been through it. Okay. It changed the whole problem. Unfortunately, I haven't done any work yet. So, start at 67, increment by 4 every cycle. Okay. So here's what I might be tempted to do. First, I'm going to put a state in here. I'm going to make it the initial state. And I might be tempted to say z equals 67. And then I could just do z equals z plus 64. And then just loop around on this. But that's not going to work because it's going to keep resetting it to 67, right?
Why are you doing 64?
Just 4.
Yeah, why is that? It should just be 4, right? I'm what I call an iterative programmer. I write the program, and then I make a list of all the bugs. There's many. And then I go and fix the bugs one at a time. So little things like that, forgetting semicolons. Okay, but this is not going to work. It's going to reset 67 every time. So I can't do that. So what I'm going to do is have it start out by initializing z to 67. That's fine. But then I need to have another state, which is just going to increment it over and over. So this one will be z equals z plus 4. Okay. And then this one it'll just loop around forever between those two, I hope. Actually, not between those two.
Yeah, if it loops back, it resets it to 7.
Yeah, it should just loop here, right?
Right.
Yeah. There we go, like that. Now, it never, it never gets reset back to 67, right? So you might say, well, this is just going to keep climbing forever. What will eventually happen? Well, 2 things will happen. If it never does go back to state 0, then z will just continue to increment. Now, it's an 8-bit number, so the highest thing you get is 255. So it'll count 67, 71, 75, 79, keep going up and up and up until it gets to 255, and then it will roll over. And it will say it was at 254, it'll add 4 more to it, and it'll roll over and end up at 3. And then it'll do 3, 7, on and on like that. So the other thing that can happen is there's always a piece of hardware that will let us reset it back to the beginning. So if someone hits the reset button, then it'll reset it back to 67 and we'll start the whole thing over again. Okay, well, let's see if this works. No.
Yeah, I got that too.
Yeah.
Only input variables may be, okay. So here's the problem it has with it. Is if you use an output, you can't do an operation on an output variable. When you go to make it an output, it can be its only function. So Z can only be put to the user if we want to operate on it and we want to do some addition or whatever manipulation with it. We need to do that on an internal variable. So we're just going to have to make another one, which I'll call I guess. Oh, they already did it for me. They've got I and J done. Okay. Well, then let's modify this. Okay, that'll probably work. And then over here, not you, okay, let's see if that makes it happy. It seems relatively happy. Okay, again, it's cutting, because of the resolution on the screen, it's cutting off the values. So let's see what happens when it gets up to 255. We'll be able to see it count a little more normally. 40, 50, and there it's going to roll over. And there it's counting by 4. So I'll just keep doing that over and over and over. Okay, I think I got it. Let's see. Nailed it. Okay. There's only one more. That's too bad. Now let's think about what we would need to make this happen. If from a data point, a data path point of view, we've got a variable and an internal variable, and we've got an output variable. So both of those are going to have to be held inside of a register. So we need 2 load registers. The reason that they insist that you don't do operations on internal variables like this is because you want, on external variables, is because you want that external output, in this case Z, to be stable for the entire clock output. You don't want it to be changing in the middle. So that's why they insist that there's no operations going on in that output variable. It's only coming straight out of a register, and that keeps it from changing mid-cycle. So, okay, we got two load registers, one called Z, one called I. We're clearly going to need an adder. So we're going to need something that'll add. One side of that will have the output of the register I. The other one will have the constant 4 on it. Then we're going to need a multiplexer, because I can be one of 2 things. I can either be the constant 67, or I can be the output. And then we don't need a multiplexer for Z, because Z is always just equal to I. So we're going to have this load register we've called Z, and the input to that load register is going to be the output of the register I. So whenever we think of variables, like if you have done any programming in the past, and it's a little bit of a shame that programming is not a prerequisite for this, but it's not. So if you have done some programming in the past, whenever you've thought as variables as something you've defined in hardware, when we define a variable, what we're talking about is a register. It's a piece of hardware that's going to hold a number. And however wide we make that register is how big of a number we've defined. So you might say in C, you might define it as a character, C-H-A-R, and that would be an 8-bit variable. Well, we would build an 8-bit register for that. Or you might declare it as an int. Well, we would build a 32-bit register for that int. So, so it's the same kind of thing, but just a different understanding of it, a different implementation of it. In C or in Java, what you're really doing when you declare those variables is putting those numbers into registers, but that's all abstracted away because you don't want to have to mess with that when you're just trying to get your program to work. You don't care what the number's stored, you just care that it got stored somewhere. Okay, so that's all the kind of components we would need here. Let's see how bad this next one is, and maybe we'll do that data path for it. While E is equal to 25, toggle U each cycle. Otherwise, U is 0, start U is 0. Okay, so U is an output bit. It's at lowercase, so they tell me that, which is helpful. Also, U have the values of 0 and 1. Toggle is a special word that I don't know if you have run across yet, but it means to flip back and forth. So if the bit is 0 and you toggle it, that makes it a 1. If you toggle it again, it makes it back to 0. It just means to flip it. Okay, so while E is equal to 25, toggle U each cycle, otherwise U is 0. All right. So here's my initial state. It tells me right off the bat that I need to make U equal to 0. Now you'll notice that all I'm doing with E, I'm not manipulating E, I'm not storing a value in E, I'm only comparing E. So E is something that's given to me from the user, from the outside. I'm getting this variable E from, it's an input to my circuit. So I don't need to store it because I'm not changing it. So it's only going to go on a transition, that's exactly right. So I'm going to insert another state. Now I don't know if this is going to be sufficient or not, we'll see. I'm going to make U equals 1. This is really my only output, is U. There are no other outputs for this circuit, so that covers it. So while E is equal to 25, toggle U. All right, so I'm going to put a transition in here, and I'm going to put another transition. Okay, no, I'm not. I'm clearly not able to transition. Okay. Seriously.
Click
Oh my gosh.
You gotta click transition and then
There, I did it. It was completely accidental. There we are. Okay, so I have two ways to get out of here, of this state now. Oh my Lord, what have I done? Okay, I think we're back to normal. So there's two ways for me to get out of this state. Or I should say to transition out of this state. One is I'm going to toggle the output. The other one is I'm going to keep it 0. And the problem statement tells me which way it ought to be. While E is equal to 25, toggle U. So if I want to toggle U, that means E needs to equal to 25. So I'm going to click on this, and the condition is going to be E equals 25. Do I have to do the double equals like in C? You do? That's a good idea. This is a special operator that means comparison. If you just put one equal, then it assigns it. So, we're not doing that. Okay, there we go. So if E equals 25, it's going to go this way. If E doesn't equal 25, so we're going to put the not sign, E equals 25. So this covers all the possibilities. Either E equals 25 or E does not equal 25. So this is all possible numbers of E are covered by these two, and that's important. If we didn't have a number that was covered by those arrows, the state machine will run into that number at some point and say, what am I supposed to do? I don't know where to go. All right. So now suppose, so we're going to forever until E finally equals 25. We're going to toggle it. Now, here is my question is, what if I get over to this spot, so I've toggled it to 1, but E suddenly does not equal 25 anymore? What should I do? I should make U 0, right? So I should go back to this state. Now let me ask you a different question. Suppose that I'm in this state and E does equal to 25. What should I do? Make it 0, right? So whether E equals 25 here, if E does equal 25, then I need to make the output 0 because it's 1 right now. If E doesn't equal 25, I need to make the output 0 because of this statement. So no matter what, it's going to be equal to 0. Make the output 0 next time. Now I could have found that by making two separate arrows and ending up with this statement and this statement on both arrows, and then realizing I'm going to go the same place no matter what.
Do you need semicolons for like transitions?
What's that?
Do you need semicolons on like
I don't think so. Does anybody know? I'm going to try it. This is, again, is my kind of iterative programming technique. I could go back and look it up, but it'd be faster for me actually just to see the errors.
It doesn't need a semicolon, because it's like a so
Yeah, it's like a condition statement, right? So, okay, so I don't know. Let's see if this works. Okay, so it's sitting there forever. Output is 0. Percentage.
you just type it in.
I could. Oh, it didn't happen. Oh, it did. It did. Why did it take so long? Okay. Now it's going back and forth. It's toggling. I hope. Yeah, it's blinking. Good. It's 26. Stops blinking. 25. Blinks again. 24. Not blinking. Okay, there you are. So now, when you go home for break over summer, and people say, so what do you do? Like, what kind of stuff are you studying? You can say, I can make a LED blink if a number equals 25. Just don't tell them that anymore. Just like, don't try to explain it. That's my best advice to you. Don't try to tell them what you do. Just go, you know, like when you open a computer and you see like there's a green circuit board in there, that's what I do. Just tell them that. And then they'll say, I think I have a virus. Can you fix my computer? No. No, I can't. So I don't know if this is working or not. Let's find out. And I think it's working. Did it? Okay.
So I have a lesson, and I've been trying to go through it, and it's just not working.
So yours is not equal. Yours is a less than.
Yeah. And it's less than 183.
Yeah.
And so it's basically like the same. Do I need like a equals or greater than equal to, or do I need just like the less than symbol?
Well, it depends on what it says. Does it say less than 183 or does it say less than and equal
Yeah, it says
183?
well, E is less than 183.
Then you should use less than it.
It's not outputting the correct.
I don't know. I have to look at it.
Okay.
All right. Let's see if we can build this one, the data path for this one, and this one's not going to be bad. And then hopefully I can get back to the previous one, and maybe we can build the data path for that one. So let's see. Okay, I'm going to try to use my technique where I put this up at the top. It's not going to work. Let's see. Okay, we can kind of see it.